Okay, let's try this. Say this is the Q4 of the last question, and usually Q4 of the last contest is usually the hardest question. So let's see if we could solve this. Okay. This is interesting. So you're given an array numbers. A subsequence is stable if it does not contain three consecutive elements with the same parity when the subsequence is read in order. Return the number of stable subsequences. Okay. Wait, you're given a subsequence if it does not contain three consecutive elements with the same parity. So that means it's not like 1, 3, 5. Like 1, 3, 5 doesn't count because they have the same parity. Parity means even or odd. Doesn't parity mean just the difference between them? Oh, it's not. Dude, it doesn't even say what parity is. Oh, okay. It just assumes you know what parity means. Where does it say that? Yeah, it's kind of dumb. If it does not contain three consecutive elements with the same parity. So, parity means even or odd. So no three evens or no three odds. So maybe we can just do something like this. We can just like create our subsets. This is a brute force solution that I'm thinking. Because I think we just need to return the number of subsets. What we can do is loop through the input. Say 1, 3, and 5. And then just try to add 1 to all of the subsets. Only add 1 to all of the subsets. Or to any of the subsets. Such that it doesn't break this condition. So there's nothing in the subset. So we're just going to add a subset of 1. Right? Then we go to 3. We go to 3. We have 1 here. We could extend this subset. So we can create 1 and 3 here. Right? 1 and 3 there. And we could also create our own. So now we move to 5. So we say 5. Can we extend this subset? Yeah, we can extend that subset. Can we extend this subset? No. Can we extend this subset? Yes. So we'll get 3, 5. And then we could just add 5 for itself. And then that counts as 6, and we just return the length. So I think all we need to do kind of is we could just keep extending the subsets, but we just need to maintain the last 3 of each one. But that's like an exponential algorithm. Because for each one, we're comparing with all the possible subsets before. How would I check that? That might TLE. How would I check? What do you mean if I could check if I could extend it by looking at the last subset? Okay, there might be a, like, do we? No, I don't need a hint yet. But that's, Basically that's the brute force. Brute force. It'd be exponential. Does that brute force make sense? We kind of loop through and then we build the subsets. But do we actually need to know the subsets? Now let me think about this a bit more. Dude, is this like some math? I'm trying to see. Because if we have 5... Okay, let's work through this example. Say we have our result here. So we have our subsets here. So we start with 2. We add 2. We start with 3. 3 could extend it, so we get 2, 3. And then also 3. 4 could extend all this. 4 could extend this one. 2, 4. It could extend 2, 3, 4. It could extend 3. So we get 3, 4. It could actually add 4 for itself too. So is this 1, 2, 3, 4, 5, 6, 7. Okay, what about 2? If we add 2 again, yeah, 2 and 2 would work. Yeah, 2, 3, 2 would work. 3, 2 would work. 2, 4, 2 would not work. 2, 3, 2, 3, 4, 2 would work. 3, 4, 2 would work. 4 and 2 would work. And then just 2 again. So 1, 2, 3, 4. Yeah, so I think my brute force solution would work, but it'd be sort of like a BFS, but then it would just be exponentially bad. Because you're comparing against all the subsets before. So is there a way that we can figure out all the subsets before that we could extend without having to loop through? So pretend I'm at a 4, right? Or pretend I'm at a 2. Like the 2 here. And I'm like, the candidate is 2. How many of these can I... Oh, I think all we need to know... Like, if we just count up, like, what if we know the number of last ending, like, the streaks for, the number of streaks for the last one? Wait, if we break... So what if we just know the ones, how many odd odds are left? So odd odds, even evens. So since we know that there's like two even evens or one even and then the rest. I think we could maybe count this evens. Last evens. Last odds. If we just maintain some variables, we could just do some math. What do you think, Chris? So it's like last even. The last even is 4. Because we need to look at, so the last even is 4. 1, 2, 3, 4. Last even is 5. Last odd is 1, 1, 2. Last odd is 2, right? Odd odds is 0. Even is 1. So if my candidate is 2, I can multiply by last evens. I can extend that. So it's gonna, we're gonna create like, we're gonna add like 5 more. 5. Because we're gonna be able to extend the last evens. And then -1, and then -1 for it because we can't do even. So we get 4. And then what about, and then like plus the odds. So we get 2 more. So that's equals 6. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. I'm trying to do some math here. Chris, are you still here? You gave me this hard ass question. Last odds. Give you 2. Plus. Yo, am I going the right direction? I think we just need to count the last evens, last odds. And then as we... And then we'll pretty much, we have to increase the last evens by 5 here. Why can't we just do this math? Look what I'm doing. Have you tried this math, the math way to do it? Like for each one, we just keep track. So let me see if this math one would work like this. Math doesn't work. So it's last even. So nothing. So we just but then we have a result. Then we just add 1 to it. So last odds is just 1. Now we go to 3. So 3, last odds, we can... So pretend we have 3, right? Pretend 3, last odds is 3. So David was good. So pretend we have 3, right? 3 times, okay. We add last even to 0. Last odds is 1. So we do 1 minus like odd odds. So we could add another 2. So this becomes 3. So but odd odds become, this becomes 1. And then the number of odds here becomes, we have to increment this. Wait. Yeah, we have to increment the number of odds that we could extend. And then we have to add plus 1. I think we could do some sort of math, man. But okay, how would we do a DP? I mean, yeah, I mean the DP top down sounds easy too. It's like you just pick one, you just sort the input because we want it in order, and you try to extend it. 1. Or I don't know if it sounds easy, but like let's just try DP 1. And then you have 3, 5. The option is 3, 5. Let's just like, let's just choose 3. 3. And then you try to go 5, but you can't anymore. But then, yeah. And then let's just say this is the root. And then maybe we try 3. And then we kind of just pass down the state of what we've tried already. So 3. Then we go 5. And then finally we go 5. So we can count 1, 2, 3, 4, 5. Oh wait. 1, 2. What am I missing? 1, 3. Oh yeah, because 1, 3. If I choose 3, I can choose 3 or not to choose 3. But if I choose, okay, so now we just kind of count it here. So we have 1, 1, 2, 3. Okay, 1, 2, 3, 4, 5, 6. Let me pull out my Excali draw. So pretend we just have a start here. We'll just start at 2. Then we have, like, you can extend it, and we just pass down. We can pass down the last 2 things it's seen in order to know if we could extend it or not. 2, 3. And then, yeah, we can get to 4 here. 2, 3, 4. Yeah. And then can we do 2? Yeah, because even, or sorry, this doesn't really count as anything. So it's even, odd, even. So yeah, we could extend this with a 2. So that, okay. Now what about 3? 3, instead of going to 4, maybe we go to 2 here. That's still good, right? So we skip 4. And then we go to 2. Instead of choosing 2, we go to 4. 4. And then we can't go to 2, that doesn't work. And what about 2, 2, right? Okay. Now we kind of have to do the same one for 3. But then all we need to do is find the path here. And then like do like n minus 1 over 2 or something to figure out how many subsequence we can create in this path. Because we can have 1. We can have like these 2, or 1, 2. Because we can have like this. We got this. Oh no, do we just have to count the paths? Okay, we just need to. Okay, I see. Sorry, I messed it up. Yeah. Okay, I get it now. I get it now. I haven't done DP question in a long time. So what we need to do is we have to do a dot here. Like, pretend we just choose 1. And then what's a path? It means we can choose 1 and we could choose nothing at all. So it could just be like, this is done. Right? Or we can choose, like, there's also a chance that we choose 1 and nothing else. So this kind of is terminal. But then we could choose 1 and then we could choose 3. But then that could be terminal as well once we choose 3. Like, choose nothing at all after that. Right? After choosing 1. And then can we choose 5? No, because it's all odd. Right? So now let's just choose 3. This could be we could just never choose anything again. But then we could also choose 5. And that could be terminal. Right? And then afterwards we can just choose 5. And then that could be terminal. So with 1, 2, 3, 4, 5. What's the answer? 6. 1. Oh no, sorry. We could choose 1, then we could choose 3. Wait, what is it? 5, 3, 5. Oh yeah, no. From 1 here, we could choose 5 right here. Like we skipped 3. But we could choose 5, and then 5 could be terminal. So 1, 2, 3, 4, 5, 6. Okay. And then like the state that we just need to pass down is what were the last 2. We just need to pretty much pass down the last 2 elements that we've visited before. So this person, the last 2 elements is just odd. So we just need to pass down, like we could just pass down a state of like odd is 1, even is 0. So this one, it just knows that the last thing was like empty. So that's like an OV1 calculation to know if we could follow a branch or not. It's kind of like a backtracking algorithm. And then yeah, it's choose or don't choose. Yeah. This is leak code. Oh, that's a Scala draw. So I think, well, why not 135? Well, because 135 it has the same parity, like all of them are odd. So what we'll need to do is take nums and sorted. Sort it. I think this is like a just like a backtracking algo. Yo, appreciate you, Shabaj. You're a legend. Congrats on your offer. Good luck at Microsoft. Appreciate you, man. Thank you. Thank you so much for the donation. I need to come up with like music or sound every time someone does a donation. I know Speed does a flip. Okay, what are we gonna do? We need to know. We need to know the nums, and we need to know the index, and all we need to know above us is last two. So if the index is greater or equal length nums. How long do I code in a day? Like 8 hours? Okay, what are we gonna do? Oh, since when? I started coding when I was 18 in college. What about you? So choose element or don't choose it. So like choose element or don't choose it. If I choose it, then I go to 1. Then I recurse. Choose element. But we can only choose element if my last two is odd equals mod 2 not equals 0 is even equals not odd, right? So choose element. We can only if nums or current number equals index, we'll say and we'll eventually return the result. But we'll do if current num if is odd and last two, we'll say odd or last two is equal to 1 1. 1 1 means that it was odd odd. If it's odd and last two not equal, like we'll do the cases we can choose it. If is odd and last two is not. Or Good luck, man. It's a long journey, but it's fun. Is even and last two not equal to 1 1, or sorry, 0 0, then we could extend it. So result, and then we're gonna do self dot result plus equals self dot backtrack nums. We're gonna do index plus 1. We'll say this becomes that one, and then next, or next element goes 0 if is even. Next element parity. 0 if is even. Am I going the right direction? Else 1. Like that. Choose it. Otherwise, we can not choose it. So we'll do result plus equals. Something like that. No way. No way. Timing TLE? No way. The hell? Oh, you can't sort it. You can't sort it. Doesn't even work like that. Doesn't even make sense why I sorted it. Please work. Please work. Time limit exceeded. How would I make this run faster? Yeah, because we're kind of exploring all paths. Yeah, it's still exponential. Maybe we just do the reverse. We calculate all possible subsets. Then we just do the reverse of just finding all of the ones that contain at least 3. Okay, now I need a hint. Where's that guy? Chris, am I going the right direction? ITL lead. Okay, let's see. Let's see if there's anything I can cash on. What is there to cash on though? Like, what is the sub problem? 1, 2, 3, 4. I don't see the. Like this. Oh, shoot. Yeah, the last two. Current number. Wait, do we just need to... What would I cash on? Let me think. It worked for this. Oh, do we need to modulo? Oh, maybe we need to modulo. Yo, it's like exponential, I think. Because we're like pretty much exploring all the different paths. So pretend we had... Like but I'm wondering... Yeah, I was trying some other solution where I was trying like some math solution initially. Like where I was counting the number of odds, counting the number of evens. Like I don't see what sub problems exist here. Mod everything, then use cache clear. That how you solved it? What do you mean cache clear? Oh, okay. Yeah, that's what I was. Trust me, I was trying to do that initially, but mod everything. Sure, I'll literally just mod everything. I wonder if that's gonna work. How would that work if it's I? But when will we ever get to an index again? Okay, let me try that. Like this. Does this actually work? How does that work? Why does that work? What's the sub? How's that a sub problem? If we're at a specific index, I'm at 5. Oh, because we don't even care about numbers really. We just need to care about odds, and evens. I don't even know how that works, man. I do not. I don't get what the sub problem is here. Okay, let's look at it in booleans and booleans. But don't we still need to explore the rest of the tree in order to find out what's gonna happen? So pretend we had like, uh, or we had like this. We had odd, odd, odd. We had E or odd, odd. How did this work? Holy crap. What's this feature? Oh, they have lead. Dude, this is beautiful. Like the agent running inside. Pause. Alpha, where'd you send it? I don't see your solution. Oh, it's loading. I don't see it, man. I don't see it. I don't see the overlapping subproblems yet. I think I need to step away from it and look at it again. Thanks for the help. Yo, Alpha, I have a slot tomorrow. We should do a mock. Like, if you want to do a system design or something too, we can do that. I have a slot tomorrow. It's been a minute. Bro, you just hear like the fire people going crazy. So. Damn, what the hell? Bro, I literally don't know how this solved it, but I need to think about it more. Like, when will we ever get to the same index again? I don't even see. Okay. This is a good one. I need to think about this question for a while. Yo, this is so sick though. I'm so happy they did this. But all right. So tomorrow we have way more people, and I hope everyone shows up. I'm actually gonna email them and make sure. I'll email them now to make sure that they actually show up. Because today a lot of people flop. But thanks as always for hopping in and coming for the coding interviews. I'm gonna continue working on some more tutorials for people, but